Okay, cool. So let's actually do the oversampling. So Juice does have an oversampler in DSP, and it's pretty easy to use. Actually, I'll just type in oversampling. So all we have to do is initialize it with the channels, the factor, the filter type, and then these other arguments. So if you create one instance of this and you want to have multiple factors, it can be kind of annoying and kind of confusing, honestly, to do this the right way. So what I like to do is create a processor class that has an oversampling in it, and I'll make 5 instances. So one of those will be off. One of those instances is 2 times, 4 times, 8 times, and 16, and then I just switch between them in the processor based on the parameter. So yeah, it's not too crazy. Let's go into C line and think I will do a new folder directory, and then we'll do DSP, I guess. And then in here, I'll just make a header called, I'll call it process block. Cool. So again, problem once, and let's go ahead and include it to get rid of that warning. DSP, process block. Okay. So let's do a namespace here, DSP, and we will make a class called process block. And it will have the basic prepare, process, and update parameters like we would have in the main processor. We also need some of the juice methods, so we'll say include juice DSP, and that should be good. All right, so we'll just set this up like a normal class. Process block equal default. Process block also equal default, I guess. Okay. Private. We will have prepare method, which will take in the same stuff as the regular one. So let's do sample rate, samples per block, and num channels. Num channels. Okay, cool. So let's add us a std unique pointer for the juice DSP oversampling float m oversampler. Cool. I will make our process spec like we normally do. We'll probably need it in the future. Okay. So we'll say spec dot sample rate is equal to sample rate. Spec dot maximum block size is equal to samples per block. And spec dot num channels is equal to num channels. Pretty simple. Cool. So now we'll initialize the oversampler. M oversampler is equal to std make unique juice DSP oversampler float. And this is going to take in the number of channels. Num channels. The factor. Oh, we need factor. Let's see here. Int factor. Okay. That's going to be 0 for 1 times, which is off, 1 for 2 times, 3 for 4. Oh, wait, no, sorry. Yeah, 0 for 1 time, 1 for 2 times, 2 for 4 times, and etc. Factor. We need the type of oversampler, and there's only 2 to choose from. So we'll go here, and it is filter type. And I like to use the IIR one because it's way less CPU. And let's go ahead and make this nicer. And lastly, we need to call init processing on the oversampler, which is kind of like prepare method for the other modules. What did I just say it was called? Init. Yeah, init processing. That's going to be the maximum block size. Easy. Now we will make our actual process method. And once we're done with this, it'll make a lot more sense. So we'll say process. I'll just call it process. We'll take in a buffer because that's what we get in the processor. Audio buffer. Make sure we take in a reference buffer. And then I like to also take in the number of samples. Oh, you know what? Let me make sure that I'm sticking with my style. So for arguments, I like doing underscores like that. So let's do that. Samples per block. Num channels. And factor is good. Okay, cool. We are going to create an upsampled audio block, and we're going to process each DSP module that we eventually include. Process samples up, do the processing, go back down, and we're good. Cool. So what I like to do is all of my DSP modules are also going to take in num samples. So I'm going to do this right here, make a num oversampled variable. So we'll say constant num oversampled samples is equal to num samples times the oversampler dot get get oversampling factor. And we need to make sure that that's an int. So let's cast that. That cast int. Yes. Okay, cool. So we need to actually do this in the processor because if we just do it and prepare or something, I guess it could get skipped over in some weird dolls that do weird stuff. So I just like putting it right there. So we're going to make an audio block. It's in DSP, not in just Juice. Audio block, float, block, buffer. So what we'll do is create an upsampled block, which is M oversampler process samples up, which is right here, and it takes in the block, which is block, which means now we would have like distortion dot process, and we'll make all of our DSP modules take in an audio block. It just makes it easy, and we'll say upsampled block. Like that. And then what we do is M sampler, oversampler, process samples back down. If we don't do that, we will crash the program. DAW is really not going to like that. And that's it. Yeah. So to make sure this actually works, we got to do some kind of processing. So do, let's do something. I don't know. I'm going to do something random like, multi multiply by, and then if we do a really big number, that should, cause some, processing overhead. So that's good. Let's go back. I think we're done. Yeah, okay. What we need to do is make an array of these. So we'll say std array of type Viator DSP process block, and we'll make 5 of those. We'll say m process blocks. Okay. And this is pretty easy. What we will do is actually we'll leave that here because we need an update parameters eventually, but we also need it here. So let's get rid of all this. So we'll say if oversampling choice is greater than or equal to 0 and static cast size t, I think the choice, oversampling choice, is less than m process blocks dot size. We will do m process blocks this, right? Yeah. We need to reference the correct index, and then we will just say process, which takes in buffer and num samples. So buffer and buffer.get num samples. So cool. This is just instead of looping through it, which is fine. This is just something that I think ChatGPT actually suggested that it could be faster. So, whatever. So what we're basically doing is seeing what the choice is, and then we are processing that one. So this has been working really well for me. I think since we put something in the process block here, I think we should be able to tell if it's oversampling or not. So we also want to, um, let's see, let's just mute the buffer. Um, what is it? Apply gain, because I'm multiplying it by a huge number. So let's just do that. And let's make sure it builds first. Oh, okay, we had something. I'm gonna run debugging, and it should take me to where the issue is. I'm sure I just made a dumb mistake. Factor oversampling. Okay. Because we didn't prepare. Yeah, prepare wasn't called. Okay, so we will just go into prepare right here, and I think it's fine to loop here. So we'll just do auto processor m process blocks, and we will do processor dot prepare. What's the order? Sample rate, samples per block, and then num channels. It's just get total. Yeah, get total num. I guess we'll do input channels for now and a factor. So this will actually be easier if we do a regular loop. So yeah, we'll do this I, and the factor is going to be I, because a factor of 0 means 1 times, and then a factor of 4 means 16 times. So that should work. All right, let's run that. Good. Okay. So let's see here. And it should be somewhat obvious if the oversampling is happening or not. So let's go here. We're going to go to plugins, plug that in there. Open up plugin doctor. Let's see if it opens. Okay, it's going to open. Good. Okay. And it is silent because I did that to the buffer. So let's look at the Oh, we're not going to be able to do that. But we are going to be able to look at performance. So off the performance is 0.1 milliseconds. Okay, there we go. 4-ish. Go to 8. We got 30. Yep. Okay. So the oversampling is definitely happening. And if we go 16 times oversampling, we have, yeah, 20 milliseconds. Okay. So yeah, it's definitely working. Great. Thanks for watching. See you in the next one.